Good day everyone, and for today's video, we are going to talk about the thermal analysis and the two techniques we have, namely the differential scanning calorimetry and the thermogravimetric analysis. Before we talk about the two techniques we have, we first should know what is thermal analysis. Thermal analysis is a branch of material science where the properties of materials are studied as they change with temperature. Several methods are commonly used. These are distinguished from one another by the property which is measured. We have here the several types of differential scanning calorimetry. I only mentioned here some of the examples. We have the dielectric thermal analysis, differential thermal analysis, dilatiometry. The two techniques we are going to tackle is the differential scanning calorimetry, the thermogravimetric analysis, and lastly we have the dynamic mechanical analysis. For the first technique, we have here the differential scanning calorimetry. When we say differential scanning calorimetry, it refers to the thermoanalytical technique in which the difference in the amount of heat required to increase the temperature of a sample and reference is measured as a function of temperature. Both the sample and reference are maintained at nearly the same temperature throughout the experiment. Generally, the temperature program for a differential scanning calorimeter is designed such that the sample holder temperature increases linearly as a function of time. The reference sample should have a well-defined heat capacity over the range of temperatures to be scanned. From these examples, as we can see, we have here the differential scanning calorimeter, which the heat flow changes is measured versus the temperature or time. Differential scanning calorimetry can be used to measure a number of characteristic properties of a sample. Using this technique, it is possible to observe fusion and crystallization events as well as glass transition temperatures. Differential scanning calorimetry can also be used to study oxidation as well as other chemical reactions. Glass transitions may occur as the temperature of an amorphous solid is increased. These transitions appear as a step in the baseline of the recorded DSC signal. As you can see on the picture, this is an example of a data we can gather from a differential scanning calorimeter, and the peaks there shows you where is the crystallization or melting point of the sample we have in terms of the temperature and the change of heat flow. The next technique we have is the thermogravimetric analysis. Thermogravimetric analysis or thermal gravimetric analysis is a method of thermal analysis in which the mass of a sample is measured over time as the temperature changes. This measurement provides information about physical phenomena such as phase transitions, adsorption, and desorption, as well as chemical phenomena including chemisorptions, thermal decomposition, and solid gas reaction. Okay, we have here the thermogravimetric analyzer and also its parts. These instruments can quantify loss of water, loss of solvent, loss of plasticizer, decarboxylation, pyrolysis, oxidation, decomposition, weight percent filler, amount of metallic catalytic residue remaining on carbon nanotubes, and weight percent of ash. All these quantifiable applications are usually done upon heating, but there are some experiments where information may be obtained upon cooling. We have here an example of data results from our thermogravimetric analyzer, and the data obtained in TGA is useful in determining purity and composition of materials, drying and ignition temperatures of materials, and knowing the stability temperatures of compounds. The data obtained in TTA is used to determine temperatures of transitions, reactions, and melting points of substance. And that's it. Thank you guys for listening. I hope you learned something from our discussion.